The Metaverse is emerging as the next big technology platform and promises to be the next frontier for human experiences on the internet. Into the Metaverse covers companies, technologies, and trends that are bringing these promises to life. Join creator and host Jonathan Ross-Friedman, founder and CEO of Supersocial, as he interviews the brilliant minds that are building, shaping, and investing in the Metaverse.
Welcome to episode 22 of Into the Metaverse, where we help make sense of the Metaverse through deep interviews with the brilliant minds who build, create for, and invest in the Metaverse. I'm Jan, and joining me today is Rev Lebaredian, VP of Omniverse and Simulation Technology at NVIDIA. For those who are less familiar, since its founding in 1993, NVIDIA has been a pioneer in accelerated computing. The company's invention of the GPU in 1999 really sparked the growth of the PC gaming market, redefined computer graphics, and ignited an era of modern AI. NVIDIA is now a full-stack computing company with data center scale offerings that are reshaping multiple industries. And as we speak, its market value is over $300 billion, one of the largest companies in the world. Rev is Vice President of Omniverse and Simulation Technology at NVIDIA, where he leads the Omniverse product, engineering, and research teams. From the dawn of the computer graphics revolution to today, Rev has always been at the cutting edge. For the last 5 years at NVIDIA, he and his teams have been combining the rendering, physics, simulation, and AI technologies pioneered by NVIDIA over a long time into a single platform for creating and simulating physically accurate virtual worlds. It's called the NVIDIA Omniverse. Prior to NVIDIA, Rev spent his career in Warner Brothers Digital, Disney DreamQuest Images, and his own venture, Steamboat Software. Rev, I am super excited to welcome you into the Metaverse today.
Thank you so much. I'm really happy to be here.
Awesome. And so, as always, a couple of disclaimers. Everything discussed on the podcast today is not a financial advice. Content is strictly educational and I believe also quite entertaining. And a quick partner announcement. Love to invite everyone to join us at MetaBeat on October 4th in San Francisco, the Metaverse event for tech and enterprise decision maker. You'll be access panels, a demo hall, networking, exclusive event hub on Decentraland, and attend live interviews by your very own Into the Metaverse. We're going to be there live, who is a media partner for the event. And I believe Rev is going to be there as well. Register for free pass using promo code Into the Metaverse podcast at metabeat.venturebeat.com. With all that out of the way, Rev, let's dig in. As we continue to build an evolving consensus around the Metaverse, the first question I like to ask every guest that comes to the podcast is, what is the Metaverse for you, for NVIDIA, and what it is not?
So from our perspective, the Metaverse is essentially kind of the third iteration or the third generation evolution of the internet. If you go back to the really early days of the internet, pre-web, the interface to the internet was text. I happened to get onto the internet back in 1989, 1990. You had very slow dial-up modems. I would dial up into a Unix machine and get a shell. And the interface was just text. It was very slow. But it was still amazing. You immediately had the superpower. You could communicate with people all over the world, the smartest people at universities and research groups within tech companies who had access to it. But it was limited. Only a small number of people in the world could actually use that interface. They were primarily computer savvy, computer scientists or software engineers who had access to it. The second iteration of the internet was when the web was introduced. And that was really remarkable because what it did was it invited millions of people and eventually billions of people to participate on the internet through an interface that was more natural to them. They could see images, text, and later on video, just like we're communicating right now on the internet. This all became possible in that era. What's happening now is we're extending the internet to become more like the real world. Our experience of the real world throughout human evolution and our animal evolution before that is through our experience of 3D spaces. And we experience each other within these spaces relative to each other inside these spaces. Our senses have evolved, our brains have evolved to ingest information about the world and around us, all the stuff around us in this context. So we're adding that to the internet. We're adding the same type of experience that we can have in the real world to the internet, which will unlock even more superpowers than previously available to us. There are many things we can predict are going to happen in the metaverse, but most of the really interesting things I think we can't really predict, just like we couldn't have predicted what the internet was going to do beforehand. So primarily for us, it's just this 3D spatial overlay of the internet. What it isn't is a specific type of experience. It's not a game. It's not a social network. It's not a physical device. There are many ways we're going to interact with it, and there's many things we're going to do in there, just like we do many things in the internet and the web today, and we experience it in many different ways.
One primary thing I want to double click on is the fact that really we don't know what the metaverse is really going to enable people to do, because it is a paradigm shift, right? We have experienced the internet from the beginning of the internet in a 2D format, at least at a large scale, right? Obviously, virtual world, 3D games have been around for the last couple of decades. That's not new. People have been playing World of Warcraft and immersed in large-scale virtual worlds since 2002, 2003. However, that's not the consumer internet or the industrial internet. And so I think one of the things that fascinates me, both with the podcast, but also as a builder in this space, is we can't even imagine yet, and the future will be built by the people who actually create stuff. And the fact that there is that change of modality from 2D to 3D is going to be pretty transformative. And so I think it's also great for the listeners to understand that no one really has perfect answers. I think we all share that sort of vision of an interoperable network of spaces where so many different things are going to happen. And the fact that it starts with video games definitely doesn't mean that this is what the metaverse is going to be about.
Yeah, I think video games are very important. Look, I'm an avid gamer. I was just playing a video game earlier today. I was playing Overwatch, getting ready for Overwatch 2.
There you go.
We love it. Especially this generation up and coming now, it's natural for them. They grew up inside 3D worlds and video games, and that's how they're going to interact with the rest of the world. If you ever want to see what's going to happen in the future of technology, just look at what's happening in the gaming space today. That's been true now for 2 decades at least. So it's really important. However, we do a lot more on the internet than play games and socialize. Those are really important, and those are big things. And we do a lot more than just consumer experiences. We do more than just buy stuff. That's a very important thing that we do there. But the internet's impact on humanity is much greater than entertainment and socialization. We're using the internet right now to record this podcast. This isn't socializing and entertainment. Well, maybe it's entertaining to some, but this is our work, right? We're communicating here about the future of technology for business purposes, for education, for many other endeavors outside of entertaining ourselves. And I think it's easy to take for granted what the internet has done to transform everything in our lives, including our work. We take email and text messaging and Slack and all these things for granted. But if you could just try to remember, for those of us old enough, what it was like before email existed, the world was a very different place, and the way we built things and the way we built companies was very different. So assuming that the internet is, well, we already know is much bigger than entertainment and socializing and consumer stuff, then of course the metaverse is going to be much more than that. But our current dialogue on the metaverse publicly is largely biased towards social and consumer types of things, which are, as they're important, but we're missing a lot of the really profound impacts it's going to have to mankind because we're not exploring the idea of the stuff outside of consumerism.
Now that we've covered a bit more on a high level, this is a great springboard to really go deeper on the core work you and your team are doing at NVIDIA. And so would love if you can take a couple minutes to share with the listeners, what is the NVIDIA's Omniverse? What is the core mission and the vision of the platform? How will it impact business and creators in your mind? And then would also be great if you could unpack your vision for this thing that NVIDIA is calling the industrial metaverse, and how does it differ from the consumer metaverse? And so threw out a lot of stuff. So maybe if we can start with what is the Omniverse and what is the core mission and the vision of the platform and how it will impact businesses and creators?
Yes, that's a great question, and I'll do my best to try to answer it succinctly. So for years, we've understood that the value of doing real-time simulation of worlds is much greater than entertaining ourselves. To date, primarily we've done world simulation in real time for video games, for entertaining. We do computer graphics in general. Most advanced computer graphics has been done for entertainment, either in visual effects or for video games. And that's been great. NVIDIA has been a big part of that from the very beginning. We helped create the whole 3D video game industry by creating the GPUs that powered that in the early days till now. But when AI showed up, deep learning, about 10 years ago, we understood that something had fundamentally changed in the force, in the world around us. For the first time ever, we could now solve computer science problems. We can create algorithms that we just had never figured out a way to create before. Humans couldn't divine how to create an algorithm that could tell the difference between a cat and a dog in an image, right? So this thing shows up, this AI thing, and it turns out that the way that you create these AIs, the way you give birth to them and train them, is by giving them life experience. We call it data. You give it a whole bunch of images and you tell it what's a cat, what's a dog, and all of that. But really, that's the same thing as life experience, the same as what we give to babies when they're born into the world. They start experiencing the world around them. They learn how to see. They learn who is their mother and father and all the people around them. Our AIs learn the same way. And at that moment, when you make that connection, you realize in order to create the most advanced AI, we're going to need to give them millions and millions of years of life experience. And we're going to have to give them a diverse set of experiences. How are we going to do that? How are we going to give them that much time and that much space? The only way to really do that is to do that in simulation. We can't do that inside the real world. It's too expensive, onerous, or practically impossible or unsafe to do that. For example, we're building self-driving cars, and we started on this many years ago. We need them to drive for billions of miles before we trust them out on the road. We need to test them and have them learn how to perceive and see what they're going to do when a child runs out in front of a car on a rainy day with fog and all of those crazy situations that would be impractical to capture from the real world. So once we realized this, we said we have to do it in simulation. That's the only way we're going to create all of the experience we need to give to our AIs. The only way we're going to give birth to them and train them. Then the next question is, well, how do you create such a simulator? How do you create the worlds, and how do you create a simulator for it? So we started by trying to adapt game engines to do this purpose. And we had some success. We built a simulator for autonomous vehicles, one for robotics. But the problems we started hitting was, although games require world simulation, they have fundamentally different requirements and different constraints over what we had with this industrial use. For a game developer, the most important thing for a game developer is to make their game fun. And making the game fun isn't necessarily being extremely accurate. Creating physically accurate worlds often is the opposite of fun. You want magic powers or superpowers and those things. The other important thing for a game developer is accessibility. You want to be able to have your game be enjoyed by as many people as possible, which means it has to run on a pretty small computer these days, because most people only have access to a gaming console, a phone, or a PC. They don't have access to a supercomputer inside a data center. So you need the engine to be really tuned to run on small computers And what you're willing to sacrifice there is physical accuracy in order to make that happen. So we decided, given this, we need to create a new kind of engine that can scale to large computers and be as physically accurate as possible, but be real time and actually super real time. We need to be faster than real time so we can predict the future before it happens. And we need a system to create these worlds that are physically accurate, that contain all of the things the real world contained in there. And it turns out that all of those things are in the real world that we're creating actually exist in some form somewhere as a 3D data, because the designers who create those things, whether they're bridges or cars or bicycles or phones, somewhere there's a CAD design of that thing that exists. So if we could aggregate all of that stuff into one world and make it as close as possible to the real world, then we have the opportunity to simulate it on this simulation stack that we're building that doesn't constrain us in terms of physical accuracy. So Omniverse does both of those things. It lets us aggregate physically accurate worlds, and then it gives us a framework to build simulators designed to be physically accurate.
That was really great way of explaining the difference also for my last question, which I asked on this point, which was the difference between industrial metaverse and consumer metaverse, right? Because of those different requirements. And I think it's captivating to think that alongside these entertaining, interactive virtual worlds that are, as you said, primarily are around play and potentially also learning and maybe even work to some extent, there is this whole world that we are emerging into, which, for a lack of a better description, we can call it a smart world or an intelligent world, where I can imagine, for example, and correct me if I'm wrong, just as a use case, I can imagine autonomous vehicle, autonomous transportation is a big thing that is happening as we speak. And do you think of Omniverse as a place where, let's say I am a car manufacturer or an autonomous vehicle fleet designer and manufacturer, do you imagine that I will be able to come into Omniverse, essentially train with billions of miles my own fleet in the Omniverse, and then at some point, of course, depending on meeting criteria and different guidelines from regulators, safety, et cetera, but I train that fleet over billions of miles in the Omniverse, and then at some point it's ready and I just deploy it in the real world and it will work? Is that sort of an example of what a use case that could be?
Yeah, that's actually precisely what we're doing. So,
okay. Well, just so everyone knows, I do not work for NVIDIA. This is just a use case.
We first and foremost built Omniverse. First off, Omniverse isn't really a place. It's like the infrastructure or the plumbing that we're providing to connect up all of this data that already exists, all the tools that exist, and also other simulators, and combine them together along with NVIDIA's unique technologies in simulation, rendering, and AI. Combine that all together so you could build such simulators. But the way we think about it, the way I think about it, and I've described in the past, is that if you have two things, if you have a connection between the real world and the virtual one, what people are calling digital twins. So you have the real world thing, whatever it is, whether it's a factory, a car, the whole earth, a molecule. And if you can capture the state of that thing in the real world and reflect it in the virtual world, and if you have a simulator that's physically accurate, you gain a whole bunch of superpowers. You get all these amazing superpowers. Just like the internet gave us superpowers, we could communicate instantly with each other around the world. The metaverse, when connected to the real world with this link, gives us some really amazing ones. The first one it gives us is teleportation. So let's take a factory as an example. We've shown many examples of the work we're doing with BMW. They build these factories that cost billions and billions of dollars. Each one is more and more complex. In some ways, the machines they design to build the machines are more interesting than the machines themselves. They're more interesting than the cars, because as the complexity of the car and the product grows, the machine that builds it grows with it. When they build these, it takes years to do it. It takes thousands of people to design this. And then they run them for many, many years. And so many people are operating it, and the factories have to evolve. anytime they were going to make a design decision, they're somewhat guessing. They don't know whether it's a good decision or not. If they alter a line in a certain way, how does that affect the employees that are working there on that line? Is it ergonomic or not? How does it affect the speeds and feeds, productivity, energy usage, all of those kinds of things? But if you have that factory modeled inside the virtual world, exactly as it is in the real world, and then you have got a link. So if you can take the state of your factory at any given moment and send that to the digital twin so that it can reflect it, the position and orientation of every joint on every robot, of the conveyor belts, of the humans that are inside the factory, their poses and where they're positioned. Essentially, the first thing you get is teleportation, because once you have that in real time inside the virtual world, anybody can go to it, just like a video game, just like an online world. And if we're simulating how it looks, how it's behaving and reflecting that, then there's no difference between you being there physically or you being there in the virtual world. They're the same thing. Then if you can record that state over time, if you can record the past and store that state, you essentially get a rewind scrub bar. You can not only see what the factory is like at this moment, but you can go back in time. You can go to yesterday and see what went wrong with the factory line at this given moment in time. And anybody anywhere in the world can go do that. They can go teleport there and go time travel back into time. Where it gets really amazing, though, is if you can somehow manage to create a simulator that's predictive of the future. If you can, given the current state of that factory, run a simulation in this engine, and it tells you 2 hours from now, you're likely to have an error or some stoppage or something somewhere in this factory here, or the speeds and feeds are going to change, energy usage is going to change, whatever it is you're measuring, then now you can time travel into the future. And if you can do that computation fast enough, faster than real time, then you truly can travel to the future and fix it before it happens. And maybe you can run many different scenarios. You can try different fixes, do many different possible futures, and choose the best one. So this is a truly profound thing that we're gaining here. The companies that are thinking ahead, I think, are going to have a huge advantage. They're going to have the superpowers of teleportation and time travel. And I think that's going to be a big competitive advantage for them over those that are lagging.
This is so extraordinary that it's mind-bending, not just to think about. I'm sure the listeners are flabbergasted, first of all, just with the notion of like real-time simulation that is basically a digital twin to what happens in real life. And then you're taking it a step further and talking about predictive simulation, which is let's envision what's going to happen in the future based on what we see at this particular time. And when you think about it in this way, I think we are able to start getting a sense of the possibilities and the impact on business, on society, on industrial companies, when we can really imagine and prove to ourselves what things are going to look like, how they're going to work, what's going to break on the way. And I know that one of the exciting projects I believe that actually NVIDIA is working on is, and would love to hear very briefly where you are in that process, predicting what do we need to do with regards to climate change and global warming. And so would love to hear for a couple of minutes, like the work you guys are doing on that.
Yeah, that's a great example of what I was just talking about. It's a digital twin of the Earth, we call it Earth 2. We're building a supercomputer and the supercomputing stack so that we can accurately model long-term what happens to our climate over decades. The idea behind it is, we have this crisis. I think most people agree we're in trouble and we have to do something. We have to do something to go fix this situation. This is where all the problems start, though. What do we do? And anytime somebody proposes an idea, inevitably it's going to be expensive and it's going to take a long time to go implement. We might not get more than one chance to do that thing. So how can we be certain or certain enough that the path we choose is the correct one, the one that's going to be worth our investment and lead to success? And so we believe that starts with first creating a simulator that we can be confident in. If you can predict the future and show that you can predict the future, accurately enough, then you have the opportunity to propose some of these fixes and go simulate them and try them out so that you can make the case to go implement those things. And the way you can do that, the way you can prove that it's predictive, is by building the model and actually running it and seeing as first, does it predict based on our historical data? And when we plug our historical data in, did it predict the future from that point in time? But we can also predict, given today, what's happening from the sensors that we have out there right now. If we can predict what happens a year or two from now, then that will give us enough confidence so that we can use the simulator to game out what are the possible solutions out there. The way we're going to do this, and the only way that's available to us right now, is through AI and machine learning techniques. Because in order to truly simulate and model climate at that scale, we still don't have computers that are big enough and fast enough to do that. We need orders of magnitude more performance to be able to simulate the future faster than it happens. Fortunately, modern AI techniques, machine learning techniques, have a lot of hope for us. They've been showing promise in terms of approximating very complex functions that require a lot of computing power while using much less computing power to do the same thing, orders of magnitude more. If you think about what machine learning is, essentially machine learning is a process by which we can take any function and we probe it. We say, we get data out of this function. You put input into it and you get output. And you feed it into this machine learning system and it gives you another function that's an approximation of that function. And if it's done right, it's actually far more efficient to run. Turns out that climate science and modeling of these simulations is one of these functions. It's a physics function. Largely, it's fluid dynamics, very complex to do on a large scale. We have developed technology, and we're doing a lot of research in an area called physically informed neural networks, as well as Fourier neural networks. The whole thing is under this umbrella we call modulus, where we can take real-world data from climate along with our models and combine it into an AI that, when run on one of our supercomputers, gives us orders of magnitude more ability to do the equivalent computation. And that will get us to the point where we can actually simulate the future climate faster than it actually happens accurately. And we've shown some great successes in the past year in this area where we can be truly predictive.
Well, very, very promising. And I think, obviously, as you said, super critical area of research for us. And I think it will likely be an amazing use case of the predictive simulations of NVIDIA and the Omniverse. I want to switch gears and talk about this, what I think of as almost like a clash of civilizations at the moment that are happening when there is a discourse about the metaverse. And there's a lot of discourse about the metaverse. And so I almost think about it as, on the one hand, there is proponents of the open metaverse. And then on the other side, there is people who are very comfortable with the way the internet looks like today. And so I want to make it very, very simple for folks who want to more actively and effectively participate in this conversation by helping them understand it in a more simple way. So when people say open metaverse versus just metaverse, which in and of itself makes a lot of people around the world a bit flabbergasted. So when people talk about the open metaverse, what do they mean exactly? And what does it mean for NVIDIA when the open metaverse is referred internally?
Yeah, I think there's kind of two dimensions to this, and they're orthogonal, right? There's the technical dimension, like we're going to build the infrastructure of the metaverse, the nuts and bolts and all of the stuff. And this is like file formats and protocols and APIs and all of the things necessary to exchange 3D information and these virtual worlds. This is where we're investing heavily and we're contributing to the open community. We've built Omniverse on top of and around universal scene description, open source standard. This is a way of describing large virtual worlds. It's created by Pixar, open source by them in 2015. And we saw it and we said, this looks like the best option for us to have an HTML for the 3D internet. And I've been piling on top of that. So I think there's that dimension, the technical one of just how do we plumb all of this stuff together? And I think by definition, it has to be open the same way HTML is open right now. And the web only works because everybody can talk to each other. The moment somebody walls off their garden and tries to do it at that level with the protocols and whatnot, you essentially isolate yourself. And so I don't think you can create enough value to be useful. The early days of the web, that was tried. I mean, we had operators who had their internet portals. We had AOL and all of those, and they disappeared because the whole value of the internet is that everybody can freely connect with each other. So we're going to see that with the 3D internet. Then there's the other dimension, which is a lot of what people are calling Web3, you know, where you have identity and ownership of items and all of that sort of stuff. So this is where, are we going to have central companies like banks and MasterCard and Visa and whatever that we have to go through for transactions? Or is it going to be distributed, decentralized, blockchains, and all of that? So in this, I don't know. I personally actually don't have much opinion in that area. Our expertise is really the former. We build technology. The computers that we build will be used for the latter, for all that stuff. They are, for cryptography and all of those things. But you can see it going both ways because, I mean, today you can go to any country and go buy something with your phone, your credit card, and it works. You know, I can do that. You can argue whether it should go through a central company or a bank or not, but it does work, and you can imagine a system being built for the metaverse that works similarly. But the other way, I think there's a lot of benefits too. What we'll probably see is some combination. Just like everything on the internet has always been in technology, there's a whole ecosystem and there's an evolution that happens and there's some Darwinian forces. I can't imagine it being one or the other.
As always in life, the truth is somewhere in the middle, either in the form of compromise or a form of consensus, but the outcome is the same. I want to double click on something we talked previously and touched upon now when you described building on top of universal scene description and kind of by definition creating the technology over a protocol that is going to be available for everyone. And obviously inside Omniverse, NVIDIA is building all sorts of capabilities, which we'll touch upon a couple in a second. But I want to talk about an announcement you guys are making this week, which is the Omniverse Cloud. And how does that, what is it, the Omniverse Cloud, and how does it fit into enabling the sort of the next generation of use cases built with Omniverse?
Well, you know, as I stated earlier, we built Omniverse to run on bigger computers. We're doing simulations that require physically accurate simulations that just require more computing in general. What NVIDIA has always done from the very beginning is build special computers that can solve the hardest computational tasks that mankind knows. Rendering for video games is a physics simulation of how light interacts with matter. It's an endless problem. Well, you can always add more and more computation, and it gets better and better, and it's never enough. You need more and more of that. The same is true for doing physics simulations in general, doing all sorts of physics, and with AI, there's no end to how much we can use. What we really want to do, though, is bring this capability to everyone, not just to people who happen to have an advanced computer sitting under their desk like I do, or an advanced notebook or whatnot. We want anybody, anywhere, to be able to use these superpowers. The only way that's going to happen is by putting these superpowers on computers in the cloud. And through the cloud, everyone will be able to access it when they need it. You don't always need a supercomputer, but you need it for moments in time, sometimes very bursty. We take for granted when we do a search. If you go to Google, you type into this little text box, type a few words in there. It looks like you're running it on a simple computer, like on your phone. But in the background over there in the data center, there's countless number of computers, all running different software stacks, touching gigabytes or terabytes of data instantaneously to give you the answer. So that's what we're building towards. With our announcement this week, this is the beginning of us taking Omniverse to the cloud so that everyone can start having these superpowers and build on top of it. And there's going to be a lot more that's going to happen over time. But this is what we designed Omniverse for, actually. We built it so that it could run on large computers in the data center and in the cloud. And now we're finally connecting the two.
It's, first of all, congratulations. And I think what's really exciting, at least from my end, also as a builder in this space and looking at companies that have really made an incredible difference in democratizing technology for creators, as you said, anyone, anywhere, at any time can build on a platform like Omniverse. And so I want to talk a bit about those creators. When you think about the capabilities that you guys are building with Omniverse, when you think about making those capabilities accessible to a much wider population of businesses and creators, what is the long-term vision of how far does Omniverse go? We talked about some really big use cases like simulation and predictive simulation of car manufacturers like BMW, which is one of the premier car manufacturers in the world. We talked about the climate issue, which you guys are doing some really great work and research there. What are some of the things that you guys envision, at least as different possibilities where really the capabilities of Omniverse through cloud are becoming more relevant and extendable to a much, much wider population of builders, developers, creators, and businesses?
We have a lot of experience building things in technology where we had no idea how it ends up getting used. The way our GPUs have been used over the years, it's always surprising to us. At the same time, we expect that's the magic of building general purpose machines. Computers by their very nature are an amazing thing. It's a device that has no specific purpose. You can do anything with it as long as you can write software on top of that.
Bicycle for the mind, I think that's what Steve Jobs said, right? Bicycle for the mind.
Yeah. You can look at all of the amazing things on our GPUs, which were the original focus was just doing pretty pictures for video games in real time. And now they're used to create robots and power the brains of robots. It's pretty profound and amazing. We built Omniverse with the assumption that most of the things people are going to do with it are going to surprise us. We don't know exactly what they're going to do with it. There's some things that we can imagine, and like the factory simulation and the Earth simulation we just discussed, we use it for a lot of our own purposes. We produce, if you ever watch one of our keynotes, Jensen's keynotes for GTC, the last 2 years or so, essentially every pixel inside, including the slides, it's not done with PowerPoint anymore. They're all 3D. He does the keynote in the Metaverse. The slides themselves are three-dimensional, and they're all built inside Omniverse. Something I maybe wouldn't have quite expected, but we ended up using it this way. We're really excited to build a powerful platform that brings the core technologies of rendering, physics simulation, and AI together and have others discover the applications and solutions for it. Already, though, we have quite a few customers of Omniverse. We're already licensing it. You've seen a lot of the announcements from our partners that are using it. I mentioned BMW earlier. We're doing with the UK Atomic Energy Agency, simulating their fusion reactors. There's a bunch of announcements coming out of GTC. One that surprised me was Deutsche Bahn, the German railway, the National Railway Agency, is building digital twins of their trains. And they need to do not just the trains themselves and the train network, but the platforms and the humans and the crowds simulated in there to make it safer for them. Lowe's, which is a big home improvement chain, is very advanced in creating digital twins of their stores and their business processes. They're using Omniverse to model their stores and make their employees more efficient. There's things I'd never heard of coming from that industry, like planograms, the whole design of how they lay out all of the products in a store.
The shelving, the layout of the store.
Shelving, very important for their businesses. Where these things are placed are very important to people who create those products. And each store is different depending on the location and the culture and the needs of the store. Lowe's gave us an example, a store that is near the beach versus one that's a mile or two inside. The planogram has to be very different. The one near the beach needs towels up front. So that's what people come to buy, and all the beach goods that might not be important elsewhere. But the planograms that they create apparently almost never match the reality, because stuff ends up in the wrong places in the stores all the time. So they're using augmented reality along with the digital twins of their stores to enable their employees to go fix this, have the real world match the planogram. So I don't know, there's already a bunch of use cases I had never thought of, I couldn't have imagined, because I'm not expert in those domains. And that's the most exciting part, to see what people do with the system that you create that was not planned, emergent.
And I think that's a great message to our audience, that as you think about the Omniverse, really is thinking about it as a general purpose technology where NVIDIA is not trying to create the applications necessarily, even though you guys are creating a bunch of different use cases, mostly to showcase what one can do with the technology. But really, it's going to be the customers, the businesses, the creators, the enterprises that are using the tech,
right,
who are going to invent the future. And I think that's what's exciting in getting access to a technology at that scale and quality. So Rev, before we wrap up, one question to finalize the episode that I love asking everyone is, what's the one thing you would like the listeners to take away from what we talked about today?
I think the main thing and the thrust of everything we talked about today is that the metaverse is much larger than entertainment, than socializing. The metaverse will actually be a reflection of our lives in our real world, the real world here. And everything that we do in the real world, we're going to be doing in the metaverse. They're going to help each other. They're going to augment each other. So imagine all of the things that we do and that are interesting to us, and extend that to the metaverse, instead of just focusing on it being purely a game experience or one that is largely for entertainment. As great as that is, I love watching movies and playing video games probably more than most people. But what's really exciting is that this metaverse thing is going to encompass everything we do and add superpowers to our normal abilities.
And we'll wrap up with that because it's so very inspiring, and I don't want to open a whole new conversation stream here. But it's almost like we have an opportunity with the emergence of the metaverse to not only extend human endeavor, but also reimagine it. Because when we're talking about these simulated environments, and I know it's going to be physics-based because it's a digital twin, but it's an opportunity to really reimagine also what should we do in real life and what could it look like in real life.
I think that's really important, and I think people have to stop right now, and everyone should be thinking about this so that we don't make the mistakes of the past with how we built the internet, where we just let it happen. I think everybody should be involved. The thing that's really, really exciting to me is that by making the internet like the real world, or much closer to it, by making it 3D and making it spatial and these experiences, we're essentially inviting people that have generally been locked out of the digital world and in the digital economy into joining. So people who are experts at creating parks and museums and public spaces, and architects and designers who do things inside the real world are now going to be necessary in the metaverse. Largely, our 2D web experiences have been built by computer scientists and software engineers, more people like me, but we're not actually the best people to go build experiences for humans to interact with each other. We have thousands of years of experts in crafts that have honed that. And so we're going to bring all those people into the metaverse. We need them to come build it with us, because it can't be just software engineers making decisions on how spaces feel and work together.
So needless to say, we're both incredibly optimistic and excited. There's going to be amazing things happening. Rev, thank you so much for joining me today. Thank you for the listeners. If you like the episode, share it, spread the love, spread the metaverse, and let's all build it together. Thank you.
Thank you, Jan, for inviting me. I really had a great time, and I could talk for a few more hours whenever you get a chance.
Amen.
Thank you so much for listening to this week's episode of Into the Metaverse. We hope you learned a lot and explored new aspects of the metaverse.